So for questions 1 through 4, we're focusing on changing this graph. So I'll start with y equals f of x minus 1. This minus 1 is outside of the function, meaning we're changing the y value. In fact, this is going to go down one place. So I go to my graph, I look at each point. The y value here is 4, and if we move it down 1, we go to 3. I'll do this for the other two main points. This one goes here, and this point goes here. So my entire graph moves down one place, and this is f of x minus 1. Now if we compare this to f of x plus 2, again, we're outside the function, meaning we're changing the y value. So this is going to go up 2. So again, I'm going back to my main graph and moving each point up 2 places. So up 2 is here. Up 2 goes here. And up 2 goes here. And I connect the points. The blue graph is f of x plus 2. So just to get a couple others, clearly this one's going to be up 3, this one's going to be down 4. So let's see. This is up 3 because we're adding 3. This one is down 4 because we're subtracting 4. Changing the y values, it works exactly as you would expect. So, okay, for question 3, I'm going up 3 places. So 1, 2, 3. This point goes up 1, 2, 3. And this point goes up 1, 2, 3. Keeping in mind that when you work with transformations, the graph should resemble what you start with. It's just either stretched or perhaps in a different location. So here for f of x minus 4, again, go to the original graph and go down 4 places. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Okay, so both questions 5 and 6, everything is happening with inside the function, meaning I'm only changing the x's. And changing the x's will be the opposite of what we expect. You would think subtracting 1 would go left, but actually this is going to go right 1 place. This goes right 1 place. And in 6, you would think this goes right 3, but actually it goes left 3. If we plot starting with 5, I go to my original graph, and I'm going to go to the right 1 place for every single point. So this point has an x value of negative 4, so it goes to an x value of negative 3. Likewise, this point goes here, and this point also goes over 1 place to the right. Here's my graph. For 6, everything is going left 3 places. Again, going back to the original graph, I go 1, 2, 3 places here. This point goes 1, 2, 3 places over to here. And this point goes 1, 2, 3 places over to here. A little bit of overlap on my pictures, but just keep in mind that the blue graph that I plotted referred to this equation here. The black one referred to this equation. In question 7, we're changing both x's and y's because we're changing inside and outside of the function. The order in which we change these will follow order of operation, meaning we work within the function first and then outside the function with subtraction second. The order in which we change the graph is first, we're going to go left 2, and then second, we're going to go down 4. So the reason is I start within the parentheses first. and I'm doing the opposite because I'm changing the x's. Second, I would do subtraction, which is subtracting 4. This is changing the y's, so it goes down 4 as I would expect. I now go to my graph, and I'm going to take each point and run them through these 2 steps. So this point goes left 2, and then it goes down 4 to this spot here. This point goes left 2 and down 4. And this point goes left 2 and down 4 as well. So the whole graph moves that way. So for question 8, we are only changing the y value because we're outside of the function, and this is multiplication. So this means you're going to multiply every y value by 2. The note I'll make to myself is there's one step, and I'm going to double the y values. If I look at this point, the y value is 4. If I double it, it goes up to 8. The y value here is 0 because you're not up or down. If you double 0, that actually stays at the same place, 0. Versus this point has a y value of 2. If I double it, it goes up to 4. This is my graph. Notice that the shape of the graph is similar, but this one's stretched. So multiplication and division will either like stretch or shrink your graph versus the previous questions where it was addition and subtraction. That like moved the graph left, right, up, or down. So for question 9, we're looking at y equals f of 2x. So here we're only changing the x value. And I see multiplication by 2, but actually what we're going to do is divide every single x value by 2. Or said another way, there's only one step happening in this equation. I'm going to take half of the x's. So if I look at this point, the x value is -4. If I take half of it, it goes to -2. So this point moves this way. The x value here is 0 because I didn't go left or right, and if you take half of 0, well, that point doesn't move either. And this point, if you take half of 2, it goes to 1. This is my graph. So if you multiply that x by 2, the graph actually shrank. You divided every single x by 2. For question 10, we're looking at 0.5 times f of x. That's changing a y value. So we're going to multiply all the y's by 0.5. Or even said another way, you could write this in here. 0.5 really means 1/2. So we're going to take half of every single y value. I'm going to divide them all by 2. So that's my one step. Take half of the y values. So if I look at this point, the y value is 4. If I take half of it or multiply it by 0.5, it goes to 2. Half of a y value of 0 is 0. And half of this value, which is at 2, goes to 1. This is my graph. For question 11, I seem to have put a typo in here. There's no x in the equation, but I meant 0.5 times x. So here we're changing just the x value, nothing happening outside the function. We are multiplying the x's by 0.5, but that really means we're going to double the x's, because said another way, 0.5 times x is the same thing as x divided by 2. So I see that division by 2, but it really means multiply by 2. I'm going to double the x's. So this x is at -4, therefore it goes to -8. This x is at 0, and if you double 0, it stays 0. And this x is at 2, and if you double it, it goes to 4. If you double all the x's, it stretches the graph, and this is my picture. Question 12 has 2 changes occurring. We're changing both the x's and the y's. Here, this 0.5 really means we're going to double the x's. Now this 2 is changing the y's, so we're actually also going to double the y's, and it's going to occur in that order. The first step is to double the x's, and the second step will be to double the y's. That means this point, first, since it has an x value of -4, goes to -8. Now the y value is at +4, so if I double it, it goes to 8 as well. The new point is -8, 8. Both the x and y value here are 0. If you double 0 for x, it stays 0. If you double 0 for y, it stays 0 as well, so that point does not move. This point, if I double the x value of 2, it goes to 4. And if I double the y value of 2, it goes to 4 as well. So you get this point here, 4, 4. There's a little overlap, but the graph looks like this. So I doubled both the x's and the y's. For questions 13 and 14, here we're multiplying by negative numbers. And what that will do is reflect the graph. So here, we're changing the y value. It's going to work exactly as I expect. I'm going to multiply by -1 to every single y. So we could actually just put that as our step, multiply by -1 to the y values. What that will do is the y value here is 4. Multiplying 4 by -1 takes it to -4. The y value here is 0. Multiplying 0 by -1 stays right where it is. And this point has a y value of 2. Multiplying by -1 takes it to -2. This is the graph. Anytime you multiply or divide by a negative, we're dealing with some type of reflection. So this is a reflection over the x-axis. You could have said it that way too. Like, hey, my one step is to reflect the y's, and that means you're reflecting over the x-axis. So by analogy, in question 14, here you're multiplying the x's by -1, which technically means we're dividing by -1, but multiplying by -1 and dividing by -1 have the same net result. So all I'm going to do is reflect the x values over the y-axis. So I'm going to write that one step as, you could say divide by -1, but it makes no difference. I'll say multiply by -1 to the x's. So this x value is at -4, so it goes to +4. This x value is at 0, so it stays at 0. And this x value is at 2, so it goes to -2. It's the original graph, but it is now reflected over the y-axis. So here we had a negative with the x's, so this reflects the x values. It might be redundant to keep writing like over the y-axis or over the x-axis. You could just say like reflect the y's or reflect the x's, and that's fine too. Okay, so question 15, we're calling the function g of x now instead of f. But the two steps are we're going to go left 1, and then we're going to double the y values. So I'm going to do that for every single point here. So if we go left 1, and then double the 4, it'll go to 8. Okay, we'll go left 1 and double this. Go left 1 and then double. Left 1 and double. So here's our graph. The whole thing moved one place to the left, and then it's stretched by a factor of 2. So here are my notes for graph 16. Technically there's 3 steps because we're multiplying by 0.5, then a -1, and then multiplying by this 0.5. But you can really put these into one step, and I think that's what I'm going to do, where I'm going to first double the x's and then reflect them over the y-axis, which will make them either positive or negative. And then after that, I'm going to take half of the y values. So going back to the original graph, I'm first going to double the x value to -10, reflect it over to +10, and then take half of it. So we're here at 10, 2. And I'll do that for the remaining points. Okay, this x value is -1. I double it, it goes to -2. Then I go to +2, and I take half of it. So we're going to get a little bit of overlap here. All right, the next point. Okay, so this one here, I'm first going to double it, make it negative, and then take half of that value. So I'm here at -2, 1. And then I'm at my last point. Okay, I'm going to double it, make it negative, and then take half of it. If I connect all these, this is the graph that I get. It's reflected over the y-axis. I've doubled the x values. It's definitely stretched out in that direction, and I took half of the y values. All right, problem 17 has 3 steps in it. I'm first going to go right 2, then I'm going to multiply the y values by -1, which will reflect them, and then I'm going to go up 2 places. So going back to this original graph, let's start with this point here. I first go right 2, then I reflect the y values, and then I go up 2 places. My final point is -3, -2. Same thing for this point. I'm going to go right 2, then I reflect the y value, and I go up 2. This is 1, -2. I go right 2, reflect the y values, and I go up 2. Same thing for this one here. Right 2, multiply the y value by -1, and I go up 2 places. We're at 7, 0. If I connect the points, this is the graph that I get. It is definitely a reflection. It's right 2 and then up 2 places. Okay, so for question 18, this 2 here means I'm actually going to take half of the x's, and then I'm going to go down 1 since this is subtracting 1 from the y values. All right, so for this point here, we're currently at -5, and if I take half of it, I'm going to go to -2.5. So we actually end up with a decimal, but that's okay. Dividing this by 2 takes me here. So this point first goes this way. Then I go down 1 place. Here I am at -2.5, 3. All right, for this point, I'm at -1. If I take half of it, I go to -0.5. If I then go down 1 place, I am right here at -0.5, 3. Likewise, this is at x equals 1. If I take half of it, I go to 1/2. If I go down 1 place, I end up at 1/2, 1. This is at 5. If I take half of it, I go to 2.5. And if I drop down 1 place, I end up right here at 2.5, 1. And if I connect my points, this is the graph that I get. It definitely shrank in the x direction and then moved down 1 place. For problem 19, technically there's 5 steps going on, but you can condense steps 1 and 2, as well as 3 and 4 into 1 step. So this 0.5 to the x means we're actually doubling the x's. The negative means we reflect it. We then deal with this multiplication. We're going to double the y's, but then also reflect it. And then the last step is to go up 2 places. So for every single point that appears here, Okay, I first double and then reflect. Now I double the y value, which goes up to 8, and I reflect it down to -8. I then go up 2 places, and I'm at 10, -6. All right, for this point, I double the x, I reflect it, I double the y, I then reflect it, and then I go up 2 places. This is 2, -6. All right, so I'm going to double this and reflect it, double the y, and then reflect it, and go up 2. I'm at -2, -2. And lastly, I'm going to double this, reflect it, double it, reflect it, and go up 2 places. We're at -10, -2. If I connect these points, this is the graph that I get. For the last one here, I think it's worth rewriting the function because it's kind of difficult to see what that 1 at the start does. Like every time we wrote the equations, the number 1 at the very end. So I'm going to reorder this. I'm going to write this as y is equal to -g of -x plus 1. Those two are definitely the same. And written this way, I can now see what the 3 steps are for this equation. First, I'm going to reflect the x's. Then I'm going to reflect the y's, and then I'm going to go up 1. So on my graph, I reflect the x, I reflect the y, I go up 1, I'm at 5, -3. I reflect the x, I reflect the y, and I go up 1, I'm at 1, -3. I reflect the x, the y, and I go up 1, I'm at -1, -1. And my last point, I reflect the x, reflect the y, I go up 1, here I am at -5, -1. And I connect these to get my graph. All right, for 21 through 28, I'm calling my function h, or capital H, and the variable instead of x, I'm using a t, but nothing really changes. The t plus 10 means I'm still going left 10, and this 2 means I'm doubling the y's. I'll run each point through that. So let's see, we go to the left 10 places to -12, and then we double this to -12 as well. So -12, -12 is where that first point goes. All right, here I'm going to go again to the left 10 places to -9, and I double the y value of 6 up to 12. So -9, +12. Okay, here I'm going left 10 to -8, and doubling the y goes up to 12, so -8, 12. 2 other points to go. Here I'm at 4, and if I subtract 10, I go to -6, and if I double the y value is 0. If I double it, it stays 0, so I'm at -6, 0. And then lastly, this point here is at 6. If I go left 10, I'm at -4, and if I double the y value, it's going to go up to +8, which is right here. So that is -4, 8. And then I connect the points. And there is my sketch. For question 22, we're going to double, in this case, the t values instead of calling them x, and also reflect the y's. So, okay, the x value here is -2, so we're going to go up to -4. And if we reflect the y, it's going to go up to +6. So that is -4, 6. Okay, here I'm going to double the t value from 1 to 2, and if I reflect the y value of 6, it goes down to negative 6, so 2, 6. Okay, this one's at 2. If I double it, it goes out to 4. If I reflect the y value, it goes down to negative 6, so that's 4, negative 6. If I double this at 4, it's going to go out to 8. The y value is 0, so if I double it, it stays 0. I actually meant to say reflect. We're on the axis, we're not doubling it. If you reflect it, it stays right where it is as well. And then this last point, if I double the x at 6, it goes out to 12. And if I multiply that by negative 1, it goes to negative 4. So that's 12, negative 4. This is my graph. I've doubled the t's and reflected the y's. For this graph, I'm going to reflect the t's, take half of the y's, and then go up 6 for the y values as well. All right, so here if I take the t value and reflect it, it goes to negative 2. If I take half of the y value, it goes from negative 6 to negative 3. And then if I go up 6 places, it goes from negative 3 to positive 3. I'm at 2, 3. All right, this point here, if I reflect the t, I go to negative 1. If I take half of the y value, it goes from 6 down to 3. And then if I go up 6 places, it goes from 3 to 9. So that's negative 1, 9. This reflects to negative 2. I take half of 6 and I go to 3. I add 6 to 3 and I get 9. This point here, if I reflect it, it goes to negative 4. If I take half of that y value, it stays right where it is. And if I go up 6, it goes to negative 4, 6. And this point here, if I reflect the t value, it goes to negative 6. If I take half of that the y value, it goes to 2. And if I go up 6 places, I end up at 8. So that's negative 6, 8. Here's my picture. I've compressed the graph in the y direction. I've flipped it over the y-axis as well, and then the whole thing went up 6 places. Here are the steps for question 24. I reverse the orders of 1, 2, 3, and 4 that I've done before. It doesn't matter if you reflect them or double, reflect half respectively first. So let's go through every point here. Okay, starting with this point, I reflect the t to positive 2. I then double the t to positive 4. The y value is 6. If I reflect it, it goes to positive 6. If I then take half of it, it goes to 3. And if I go up 5 places, I end up at 8. That is 4, 8. All right, so for this here, I'm going to reflect the t. I'm then going to double it. I then want to reflect the y down to negative 6. And then take half of it, going to negative 3. And then if I go up 5, I end up at positive 2. This is negative 2, 2. All right, so this point here, I'm going to first reflect, then double, reflect the y, take half of it, and go up 5 places. That's negative 4, 2. This point, I first reflect it. I then double that negative 4 to negative 8. I reflect the y and take half of the y. That does nothing since the y value is 0. I then go up 5 places. I'm at negative 8, 5. I'm at my last point. I first reflect it to negative 6. I then double it to go to negative 12. I then reflect the y, which goes to negative 4. I then take half of it, going to negative 2. I then go up 5 places to positive 3. That's negative 12, positive 3. And when I connect my points, this is the graph. It's reflected over the t's, reflected the t's, I doubled them, reflected the y's, and took half, and went up 5 places. For questions 25 through 28, those are definitely a bit more challenging, so if you're interested in trying them, give them a shot, and I'd be happy to go over them with you. But I want to move on to questions 29 through 34, which is all done directly in your calculator. So for all these problems, I set my window for the following values. So my screen goes from a negative 20 to a positive 20, then a negative 20 to a positive 20 in all directions. I wanted to choose a window that would work for every single question. Also, I put my x scale and y scale at 5, and this means that every mark is counting by 5. So it goes like 5, 10, 15, 20, negative 5, negative 10, negative 15, negative 20, and so on. For 29, I want to look at the graph of x squared plus 4, and this is how I entered it in place of y1. So all I want to see here is, if we're starting with the graph y equals x squared, can we understand this graph from a transformation? I see this plus 4, and it's outside of my function, and I know that means go up 4. So if the original graph of x squared is here, did the graph go up 4 places? And the answer is yes. This graph went up 4, and this matches with what I see on my graphing calculator. So that's all I'm looking for the remaining questions, questions 30 through 34. Graph the function I give you, check out what you see on your screen. Does it go left, right? Does it reflect? Does it stretch? And so on. For question 30, again, the starting point is the graph y equals x squared. And here I have x plus 4 squared. And the way this is written is that we're changing the x value. And this plus 4 should mean that the graph goes left 4 places. And if you check it out, it does. Every point here goes this far to the left. So again, this idea of adding, doing the opposite makes sense with my picture. For question 31, the graph of x squared, again, is this shape opening upward, and here this appears to be upside down. If I check out the transformations that appear here, there's now 2 different things. The first thing is a reflection, so that means you're going to reflect the y's, and then you're going to go up 5 places in that order. So the first thing is this graph first goes upside down, but then the whole thing moves up 5 places, so this matches up with this graph. So this graph should go right 5 places and down 5 places. Again, I'm changing my x's, then I'm changing my y's. It started here, and the picture I ended up with moved over 5 and down 5. So yep, this matches too. For question 33, this is negative x squared, and the negative is in parentheses. Probably no surprise here, but if you reflect the x's, that means you're reflecting it over this axis. Well, the graph is symmetric over that axis, so it looks exactly the same. And in fact, it is. It looks exactly like the graph of x squared. And the reason for that is, if you don't look at a graph, but you square this thing out, you square the x, you square a negative 1, which makes it positive 1, this thing should be, in fact, be equal to x squared. So anyways, you can think of it in terms of transformation, but we get the same graph. And for my last graph, this is what I have. Y equals 2 times x plus 15 squared. So the graph has to go 15 places to the left, and then we double the y's. And that's why I had to choose this larger window for every single graph. You start here at 0, you go over 5, 10 to negative 15, and then the graph itself, if you just had x plus 15 squared, it would be a little bit lower than what appears here. So here you're doubling the y values, which is stretching it away, and that is my picture.